Hey guys, this question wants to know what is the major product of the reaction shown? Okay, so if we look at it, we can see it's sort of a simple alkene addition reaction. You should definitely know all your alkene reactions. Remember, for each alkene reaction, always ask yourself, do I know what the regiochemistry is of this reaction? In other words, is the thing I'm adding going to add anti-Markovnikov or Markovnikov? And then also ask yourself, do I know the stereochemistry of this reaction? In other words, are the things that I'm adding, are they adding on the same side? Is it a syn addition, or are they adding on the opposite sides? In other words, an anti-addition. If you know those two things of every single alkene addition reaction, you should be good to go. All right, so clearly hydrogenation we know it's neither syn or anti, because you're adding, it's neither an anti-Markovnikov or Markovnikov, sorry. The regiochemistry is going to be neither, because you're adding two hydrogens, okay? So there's no reason to say which one goes where. And in terms of the stereochemistry, it is a syn addition, okay? So in other words, both hydrogens add to the same side. The mechanism for this reaction is kind of not well understood by most organic chemists. It's something that's known as, they call it surface chemistry. Basically, simply put, you can think of it as the platinum or the palladium metal basically coats itself in these tiny little hydrogen atoms. Kind of think of it as sort of as a hedgehog. And so therefore what happens then is the alkenes will fall on this porcupine-looking structure. It will fall down like this, and as they fall down, the one carbon will touch that hydrogen, and the other carbon will touch that hydrogen, but it'll be on the same face, and therefore it's a syn addition. So we know it's going to add on the same side. So now all we're left to do is we're looking at all these answers, and they're all given in Newman projections, and kind of figure out which one makes sense from the product that we're given. All right, so I look at answers A and B, and I can already rule these two out. And that's relatively simple, because if you notice, you'll see that this hydrogen and this hydrogen are both attached to the back carbon there, okay? And that's not going to happen. My one hydrogen will go to the one carbon, and the other hydrogen will go to the other one. I'll basically get this, right? One hydrogen there, the OH here, phenyl, hydrogen, and CH3. Like, this is what my product will look like this. I'll have a hydrogen on each carbon. Let me just make sure my handwriting isn't too terrible. Okay, so those are the two hydrogens I just added. They're not going to add to the same carbon. So therefore, A can be ruled out, and the same goes for B. And B, they're just both added to the same face. Answer choices C, D, and E are all added to the two separate carbons, so therefore those are all still possible. Okay, but now let's work a little bit backwards from these answers. Let's take answer C, for example, and I want to see what alkene this came from. But since I know that my hydrogens add in syn fashion, they add from the same side, I know that the very moment after they were added, these two hydrogens were eclipsed, right? If they're adding to the same face of the alkene, the very moment that they were added, those two hydrogens were both sticking up in the same plane. So let's rotate the back carbon so that these are eclipsed. So if I do that, I get the front carbon stays as is, and the back carbon, I'll see the hydrogen there, I'll see the CH2, CH2, OH here, and the CH2, CH3, the ethyl group over there. So in other words, the ethyl group's on the same side as the phenyl, and this hydroxyl, ethyl hydroxyl will be on the same side as this methyl group over here. So now if I look at that real quick, let's see if that agrees with my answer, so with my starting product. In my starting product, I see that the ethyl and the phenyl is on the same side, just like my product here, and my hydroxyl group's on the same side as the methyl, just like I have over here. So therefore, I know that answer choice C will be the correct answer. If you do the same thing with D, you'll see that the hydroxyl will be the same side as the phenyl, and so that will be incorrect. And you can play around and do the same thing with E, and you'll also see it is incorrect. So the correct answer is going to be C for this one. This is a great question. It's a great way of thinking. It kind of tests your knowledge of stereochemistry and of your alkene additions. So sort of it covers two subjects at once here. If you have any questions on this, if you're confused in any way, feel free to shoot us an email, and we'd be very happy to explain things in more detail. All right, guys, thanks for watching. Have a nice day.